Hello everyone, welcome to our channel 2 Bits. This is our fourth video on the linked list series, and in this video we will be discussing the question linked list cycle. Now in this question we are given a head of the linked list and we need to return true if there exists a cycle in the linked list, otherwise we need to return false. Now a cycle is detected in a linked list when a node is reached again by traversing the next pointers. So for example, when we go from 3 to 2, we have visited 2 once, then when we go to 2 to 0, we visit 0, then we go to 4, we visit 4, and again after 4 we reach 2, but 2 has already been visited. So there is a cycle in this particular linked list. Now in this linked list we see that when we go from 1 to 2, 2 to 3, 3 to 2, and 2 to 4, and in the end we reach null. So there is no cycle in this particular linked list. So in this we return true, and here we will return false. Now let's see the first solution that you will be telling in an interview. Now in this solution, we can make use of a hash table to store the nodes which are visited. Now if we reach a node that has already been visited, then that means there exists a cycle. Now we need to store nodes and not just the value of the nodes, because for example here we have 2 and we have another node which has the value 2. So we cannot store the value. So we need to store the complete node. So you can make use of set in Python. So what we will do is we will start traversing from the head node. As we traverse a particular node, we will store it in our hash table. For example, here we store 3 as a node. Then when we reach 2, we store 2. Then we reach 0, we store 0. Then we reach 4, we store 4. Now from 4 we again reach 2, but as we know we have already visited 2 once, so that means the node is repeated. So that means there exists a cycle, and we will stop here and we will return true. Now in this case, when we traverse, we will store 1, then we will store 2, then we will store 3, then again we store the node 2, then we reach 4, and in the end we reach null. Now as we have reached null and there is no repeated node, we know that there is no cycle. So we will stop here and we will return false. Now let's see the time complexity of this particular solution. The time complexity will be of order n, as we are traversing the whole list to check whether the node is repeated or not. And the space complexity will also be of order n, as we are making use of a hash table to store all the nodes, and then we check whether any node is repeated or not. Now let's move on to our optimized solution. Now in this solution, we will take 2 pointers, a slow pointer and a fast pointer. So we will move forward slow by 1 step and fast pointer by 2 steps, and if there is a cycle in the linked list, then these 2 pointers are bound to meet at some point, and if they meet, then that means the cycle exists. Otherwise, if the pointer reach null, then that means the cycle does not exist. Now if a linked list has a cycle, then that means it can never reach null. So there will be no case in which the pointer reach null. So let's see first how this happens. So as we said that the slow pointer will move by 1 step and fast pointer will move by 2 steps. In first iteration, the slow pointer moves by 1 step and the fast pointer moves by 2 steps. So fast pointer reaches 3. Then in next iteration, the slow moves by 1 step and the fast pointer moves by 2 steps, so it will go to 4, then it will go to 2. And in next iteration, the slow pointer goes to 4 and the fast pointer moves by 2 steps, so from 2 it will go to 3, and from 3 it will go to 4. So now we can see that both slow and fast point to 4. That means there exists a cycle. Let's see it with another example. In this example, we first point slow and fast pointer to the head of the linked list. Now in next iteration, the slow will move by 1 step and fast will move by 2 steps, so it will reach 3. Now in next iteration, slow will go to 3 and fast will go to 5, and in next iteration, slow will go to 4 and fast will go to 7. Now slow moves to 5, fast moves to 2, and again slow goes to 6 and fast moves to 4. Now slow moves to 7 and fast moves to 6. Now slow moves to 8 and fast, which is at 6, will go to 7, then go to 8. Again, slow and fast pointer are pointing to the same node, then that means cycle exists. Now let's see why the solution works. This is a cycle. The slow pointer is pointing to the first node and the fast pointer is at the fourth node. When the slow is at first node and the fast is at fourth node, the distance between them is of 5. As you can see, 1, 2, 3, 4 and 5. So the distance is 5. Now in next iteration, slow moves to 1 step, the fast will go to 2 steps. Now when the slow is pointing to 2 and the fast is pointing to 6, we see that the distance between them has decreased to 4. Now again in the next iteration, slow will move forward by 1 and fast will move forward by 2, so it will reach 8. So when the slow pointer reaches 3 and the fast pointer reaches 8, we see that the distance becomes 3. Now in the next iteration, when the slow pointer reaches 4 and the fast pointer will go to 2. So when the slow pointer is at 4 and the fast pointer is at 2, we see that the distance becomes 2. Now again the slow pointer moves forward by 1 and the fast pointer moves forward by 2. Now in this case, we see that the distance between them becomes 1. And in the next step, when the slow pointer moves forward by 1 and fast pointer moves forward by 2, the distance becomes 0. As we can see that after each step, the distance decreases by 1 step and in the end it is bound to reach 0. So if there is a cycle and we move the slow pointer by 1 step and the fast pointer by 2 steps, so the slow pointer moves forward by 1 unit and the fast pointer moves forward by 2 units. We can also imagine that the slow pointer remains stationary and the fast pointer moves by 1 distance. So in each step, distance between them decreases by 1. So if there is a cycle, they are bound to meet. So we can use that logic to detect a cycle in a linked list. Now let's see the time complexity of this particular solution. The time complexity will be of order n and the space complexity will be constant as we are not using any extra space. Now let's see the Python solution for this particular question. So in this solution, first we check if the head is already null or not. If the head is already null, then we simply return false as there cannot be any cycle. So as we have discussed, we take two pointers, slow pointer and fast pointer, and point it to head. Now we will iterate till we do not reach null. So if we reach null, then that means there exists no cycle. So this while loop will go on till either fast.next is not null and fast.next.next is not null. So this will go on until we find any null. So fast pointer will move forward by 2 steps and the slow pointer will move forward by 1 step. So if in any case the fast pointer is standing at the same node as the slow pointer, then that means there is a cycle. So we will return true and we will come out of the while loop. Otherwise, we will find a null and this loop will break. So we will return false then. So this was the Python solution for this particular question. The link for the C++ solution is in the description and the link for our Telegram channel is also given in the description. So please check out and do join our Telegram channel. Thank you for watching. If you liked the video, then please like, share and subscribe to our channel if you haven't done that.